the product of sine and cosine. As you can see, sine and cosine. And if you look at the power, we have odd and even powers. So our target will be on the odd power. So the first thing we need to know is that, okay, let me just shift this to save space. The first thing we need to know is that if the power of sine is odd, then our u is cosine. And or if the power of cosine is odd, then our u is sine. So very, very important. So since in this I'm using this, since we substituted u as cosine when the power of sine is odd, what do? We need to bring in cos in the equation. So the function will be written as a function of cosine only, since we substituted u as cosine. Why here, once you substitute u as sine, you need to write it as a function of sine. And there is an identity relating sine and cosine. We need to use it again. So if you could remember our Pythagorean identity, that sine squared x plus cos squared x is 1. So making both sine squared and cos squared the subject of formula. That's what we have. So very, very important. So this is the first thing, this one, while that is the second thing we have to know. The last one, we need to use half angle formula. That's cos, or double angle formula, depending, that cos 2x is always equal to 1 minus 2 sine squared x, or is equal to 2 cos squared x minus 1. So making sine squared the subject of formula in the first one, we have 1 minus cos 2x over 2, and making cos squared x, we have 1 plus cos 2x over 2. So these are the things that we are going to use to solve this. So the first one now is the integral of sine x raised to the power 8 cos x raised to the power 3x dx. So what do you notice? That the power of cosine is odd, so meaning our u will be sine. So we need to write others in terms of sine, and we know that the derivative of sine is cosine, so we need to save a cosine factor here. So we can write this as integral of sine 8x cos squared x times cos x dx. Yes, because u will be sine here, so we need to get a cosine factor, because if you differentiate sine you get cosine. That's why we need to have one factor of cosine if u is sine, and one factor of sine if u is cosine. So that's it. And we need to write this, remember, because our u here is sine, we need to write this in terms of sine. So if you could remember this, we can write this as integral of sine 8x cos square x is 1 minus sine squared x times cos x dx. So finally, we're almost done. So we are now good to go. So if you let u be sine x, remember, because cosine is odd, if you differentiate, that's the u dx is cos x, so the u is now cos x dx. Do you see it now? Why we have to save a factor of cosine? So we now have that integral of u raised to power 8 times 1 minus u squared times du. So which is the same as integral of, you open up, u raised to power 8 minus u raised to power 10 du. So we now integrate, which is now u raised to power 8, u raised to power 9 over 9. That's the basic integral. Basic integration 9 minus u raised to power 11 over 11 plus k. But remember, we say u is what? Sine x. So this is now sine x raised to power 9 over 9 minus sine x raised to power 11 over 11 plus k. So that's a nice question. So let's finish up the second one. We are given the integral of, so the second question, we're asked to integrate cos 6x sine, I think sine 5x. That's 5 cos x raised to power 6 times sine x raised to power 5 dx. So what do you notice? The odd power here is sine, so our u will be cos. So we'll split this as integral of cos x raised to power 6. Why this? We must save a factor of sine since u is cosine. So this could be written as sine x raised to power 4 sine x dx. So we are still going. We now use our Pythagorean identity. Our u is cos x since sine is odd, so our u will be cos. So we'll write this as, remember, sine squared x is 1 minus cos square x, so raised to power 2. Do you get? Sine square x is 1 minus cos square x, so remaining 2. 4 is 2 times 2, so that's why this is sine squared x times 2 is 4, so that's it. Sine x dx. So if you now let u, I've said it before, you need to know, equal to cos x, you now have integral of u raised to power 6. Why this is 1 minus u raised to power 2 times 2. Okay, here the u is that. If you differentiate with respect to x, we now have minus sine x dx. But if you notice, there is no negative here, so I can negate this and counter it. Do you get? I can counter this with negative negative. So I can write this negative and counter with the negative outside. So I now have negative because of the derivative. And what's negative? That, so this is now du, because there is negative, negative is positive, so minus sine this thing x dx is now du. You see the negative sign. So we'll still open up this integral u raised to power 6. So you open up, this is 1 minus 2u squared plus u raised to power 4 du. So this is now equal to this times minus times, that's minus u raised to power 6 times that. We'll have integral of minus u raised to power 6 plus 2 u raised to power 8 minus u raised to power 10 du. So we now integrate. So we'll continue. So let's integrate. So this is minus u raised to power 7 over 7 plus 2u raised to the power 9 over 9 minus u raised to the power 11 over 11 plus k. But we say that u is cos x, so we now have, or u is cos x, therefore our answer is now minus cos 7, that's x, cos x raised to the power 7 over 7 plus 2 cos 9x over 9 minus cos 11x over 11 over this 9 plus k. So that's our answer. So it's a very tricky question, but you can still solve it the same. Thank you.